In this video, in order to give you a feel for what a motion map is, I'm going to have you observe a real object moving while I make a motion map on this table. The object that I have is a small battery-operated train, and this train moves at a constant speed. I'm going to have a metronome ticking in the background that makes a ticking sound every 1 second. Watch what happens. As the train begins to move, I'm going to move one of these nickels in place to make a marker at the front of the train every second. What I've done there is I've created a record of where the train was at every second during the time it was moving. And that's the heart of a motion map. It's just a spot or a point that shows where it was every second. Now, I'm going to do more than that, and a good motion map should have more than that. It should have a velocity vector attached to each point so that we know relatively how fast it was going, and also we know what direction it was going. So I'm going to add some arrows, some vectors to my motion map. If I start at the first point, I know that it was moving in the direction toward the second arrow. So I'm going to draw that arrow. That vector represents the velocity of the train when it was at the first point. When it was at the second point, well, it was moving the same speed because this is a constant velocity vehicle. So I'm going to draw an arrow that's the same size towards the next point. I'm going to do it again. Because it's a constant speed train, the size of all these vectors should be the same. That's essentially what a motion map is. The train was actually still moving at the last point, and so I probably should draw another vector. I don't know if it fits on my screen, but it should be the same length because its velocity was the same. So the points are the positions, the vectors, the arrows, those represent the velocity. If the train weren't moving at constant speed, well, the arrows would be different lengths, and also the spots would be at different distances. But this is a constant velocity motion that you're seeing here. You'll notice that as I drew the arrows, I drew them from one point all the way to the other point. That was an easy way for me to make sure I was making my arrows the same length. And it does truly represent the velocity at some scale for the velocity vector size. Now, this can be applied to objects that you haven't seen move, and you can imagine where the points would be if a particle was moving at constant speed, or even if the speed was changing.